A warm good afternoon to one and all present virtually with us today. On behalf of the organizing committee, I take the pleasure to extend a hearty welcome to Dr. Sister M. Rashmi AC, Principal, Patna Women's College, Dr. Sister M. Tanisha AC, Vice Principal, Patna Women's College, Dr. Kunal Kumar Das, former scientist, Indian Institute of Remote Sensing, Dehradun, the faculty members, researchers, and students from different colleges and universities at the national webinar on environmental hazards and disaster management using geospatial technology, organized by the Department of Geography, Patna Women's College, Autonomous, Patna University. To begin this virtual event on a devotional and prayerful note, may I now call upon Sister Anna AC, Assistant Professor Geography, Patna Women's College, to lead all of us into a divine world of prayers.
Let us place ourselves in the presence of God, Almighty and ever-living God, Creator of the universe. We thank you for the blessings of this day and all the goodness we have shared and experienced. We thank you for the beauty of creation, its richness and variety. We cherish, nurture, and care for this unfathomable gift where we experience your presence, faithfulness, unending love and care. We entrust ourselves and the entire humanity into your care as we listen to the hymn being played for us.
All-powerful God, filling all the universe and the smallest of your creatures, you embrace all life with tenderness. Oh yeah. Pour out the power of your love that we may protect life and beauty. Fill us with peace that we may live as sisters and brothers. We thank you. Whoa. We thank you. Whoa. We thank you for being with us every day. Hey, hey. We thank you. Whoa. We thank you. We thank you for being with us in every way. God of the poor, help us to rescue the lost and forgotten of this earth. So precious in your eyes, oh yeah. Bring healing to our lives and we'll protect the world from all this confusion. Touch the hearts of those who look only for gain at the expense of the earth. We thank you. We thank you. We thank you for being with us every day. Hey, hey. We thank you. We thank you. We thank you for being with us in every way. Teach us, oh God, to discover the worth of each and everything, to be filled with awe and contemplation, oh yeah. To see we are united with every little thing as we journey to your light. Encourage us, we pray, to work for justice, peace, love, and understanding. We thank you. We thank you. We thank you for being with us every day. Hey, hey. We thank you. We thank you. We thank you for being with us in every way.
Thank you, sister, for invoking God's blessings for all the delegates present with us on this virtual platform today and for the success of today's program. There are some instructions for the participants. I request all the participants to kindly keep your microphones muted. Otherwise, we may have disturbance for all of us. So once again, I request all of you to keep your microphones muted. At the end, one feedback form will be sent to you. The link will be there in the chat box. You are requested to click the link to fill the feedback form. And on the filling of the feedback forms, you will be receiving your e-certificates of participation within a couple of days. So kindly keep that in consideration. Thank you. No society in this world is free from hazards and disasters striking our physical environment. And to a considerable extent, mitigation of these catastrophic events are often beyond the human capacity. Going with the deterministic approach of human geography, we must admit that it is the nature, the environment, that has the supremacy to a great extent over human actions. Then what should be the solution? What must we do to combat, control, and curb the environmental disasters? And here lies the vital role of disaster management. Disaster management as a discipline and as a practice has come a long way from the conventional post-disaster rescue and relief operations to more effective and properly planned preparedness and mitigation strategies. These strategies during the recent years have relied very much on technically advanced and scientifically modern geospatial technology, the term used to describe the range of modern tools and techniques contributing to the geographic mapping and analysis of the Earth and human societies. And for obvious reasons, the geospatial technology as a whole has become an integrated, well-developed, and successful tool in disaster management and disaster mitigation. For the educators and learners of geography and allied sciences, the purpose of today's webinar has been to gain meaningful insight regarding the role and efficacy of various modern techniques in management and mitigation of environmental disasters, the natural calamities we all are confronted with at some time or the other. I now request Dr. Debjani Sarkar Ghosh, Associate Professor and Head, Department of Geography, Patna Women's College Autonomous, to throw light on the focal theme of the national webinar in her convener's address. Over to you, Madam.
Thank you. Good afternoon and a warm welcome. In the national webinar on environmental hazards and disaster management using geospatial technology, where we have joined virtually. Environmental hazards and disasters are the major issues in the present context. With the advancement of modern civilization, hazards and disasters are playing havoc. With global warming and climate change, cyclones are frequent, monsoons are harsh, heat waves are deadly. Now, what's the difference between the hazards, disaster, and how we can manage or we can mitigate the effect of the disaster? Hazard is a situation which is a threat to human and environment. It is those extreme events which exceed the tolerable magnitude, result in losses. But not all hazards are disaster. If a hazard occurred in a uninhabited area or over the ocean, that might not be considered as a disaster. On the other hand, disaster is an event or incident produce destruction to human life and property. It occurs rapidly, instantly, and indiscriminately, and it leads to loss of property, life, and overall loss to the civilization. Environmental hazards and disaster management includes the disaster risk reduction, disaster mitigation, preparedness, disaster response, and disaster recovery. Now, what about geospatial technology? Geospatial technology can play a major role in managing hazards or mitigate the effects of disaster. To reduce the intensity and control the impact of hazards and disasters, modern geospatial tools like remote sensing, GIS, GPS are widely used. Geospatial data are the takeout of this geospatial technology. Now, the features that are impacted by disaster are geographically located and have geographic addresses. Geospatial data helps the disaster management information cell to prepare, to assess the damage, and to plan for as well as evacuation. It can provide information about the area that are susceptible to the flood and location of the people and livestock that should be evacuated in case of disaster. Thus, we can see that GIS, GPS, remote sensing, they are very useful technology and can play a major role in disaster management. They have been used in the evaluation of geo-environmental catastrophe by providing a sort of synoptic coverage of a very broad area in a cost-effective way. To know the intensity, damage, and ways to provide immediate help of any disaster, accurate and almost instant data is required. This data can be provided by satellite images through remote sensing, and we have seen it during different cyclonic period. It helps the administration to prepare for the disaster. So if we see it's the cyclone figure where we can see that satellites provide the early warning and movements of the cyclones. They also give the long-range climate modeling for the climatic hazards. It also gives mapping area for the escape routes. So the severity of the cyclones can be identified by remote sensing data. It gives risk modeling for predictive analysis and movement of the cyclones. Cyclone affected area can be mapped through satellite images. To study cyclone hazards and disaster, QuickSat Radar Kalpana 1 satellites are used. When there is any earthquake, it brings a lot of disaster if it occurs in a populated, densely populated area. The geospatial technology provides impact assessment and damage assessment for the earthquake disaster. After the strike of the earthquake, remote sensing data can be used to prepare earthquake-affected region maps. With the help of current and previous data, comparison is possible for damage assessment and building stock assessment. Different satellites are used for monitoring the earthquakes and its after effect. When there is flood, remote sensing data can bring lot of use to the administrator. In flood affected area, remote sensing plays effective role for making flood areas mapping, evacuation of flood affected people, forecasting of the future movement of the flood water, and this can be done by using satellite data for detecting flood hazards and its management. If there is landslide, which is very common in mountainous and hilly area, remote sensing data can help us a lot. A comparative study is possible with pre and post image of the same area. Different satellites like IRS, INSAR, SPOT, etc. help to identify the problem. Now, if we think about GIS, which is Geographic Information System, it's a software-based technology. It can be a lot of useful in emergency situation and hazard mapping from various sources. Maps help administrators to take the correct decision. It also predicts the level of damage, forecasting of the water level in case of the increase in the water of flood water. In case of the volcanic eruption, it can predict about the movement of the lava flow also. Thus, it helps to create hazard inventory map, vulnerability assessment, etc. If we have GPS, which is Global Positioning System, which is satellite-based navigation system, that is of much use in identifying geographic location of a hazard or a disaster area and the people who are affected due to these disasters. GPS plays a major role in locating a disaster place to reach and help the affected people. Thus, we can see geospatial technology helps to identify the safe location, evacuation, and management of the rehabilitation. These techniques are helpful in impact assessment and provide necessary help by preparing relevant maps and models. With global warming and climate change, the number of disasters are expected to increase. To combat the situation, the help of geospatial technology is a must in a modern day living. But these are all rudimentary information that I have provided you. Let's listen from the expert how these technologies can bring benefits to humankind for its survival. Thank you.
Thank you, Dr. Devjani, for explaining the webinar theme, with precision and clarity. Thank you, Madam. Once again, I request the participants to kindly keep your microphones muted. Thank you. It is our proud privilege to have Dr. Kunal Kumar Das, former scientist, Indian Institute of Remote Sensing, Dehradun, as the resource person for today's webinar. Dr. Das completed his doctoral research from University of Twente, the Netherlands, under the Inverted Sandwich PhD program and was awarded PhD from HNB Garhwal University, Uttarakhand. Your areas of specialization and special interest have been geospatial science, satellite navigation, climate change implications, forestry, land use dynamics, biodiversity assessment, and protected area management. In his long career of 40 years, Dr. Das has been associated with a number of high-ranking Indian as well as overseas organizations. The Indian Space Research Organization, ISRO, Center for Space Science and Technology Education in Asia and the Pacific, affiliated to UNO, Dehradun, Indira Gandhi National Forest Academy, Dehradun, Shah Jalal University of Science and Technology, Sylhet, Bangladesh, and University of Leading, Sylhet, Bangladesh, to name a few. Sir has also been awarded for his lifetime research contributions made in the area of remote sensing, biodiversity mapping, and forest conservation, conferred upon by the International Conference on Global Biodiversity, Climate Change, and Sustainable Development, Rajiv Gandhi University, Arunachal Pradesh. May I now sincerely request Dr. Kunal Kumar Das to share your expertise with the participants of the national webinar. Over to you, sir.
So thank you, madam. I am very much honored to be amongst you today. This is a wonderful afternoon here, and I've gone through the brochures you have already uploaded here. I don't think that any institution is there which is more than your capability. This is a wonderful institution, Patna Women's College. And I am very much happy to see that a lot of work is being done in remote sensing and GIS field there. So I've captured one of the photographs where the students are working in lab, and that is really wonderful. That's heartwarming things for me. Now, in today's lecture, presentation, which I am going to discuss with you, is the environmental hazards and disaster management. And there we're going to use a geospatial technology. As Madam Devjani Sarkar already said that what are the beauties of geospatial technology. So I'm not going to touch upon those things. But then what are the things going on right now all around the world that we can see? And this is very useful for the students, those who are in undergraduate courses, those who are doing research work also, because I would like to share something like modeling also. Okay, so like that. No, that I'm going to touch upon so many things here. Okay, briefly going to touch so that student can have some idea that what they can do in their future. So I'm going to present my presentation here. It's like this. Here we are. So actually, I'm very happy that the students are doing a lot of work in. Seems to be they're working on that satellite remote sensing data the on-screen digitization they are doing or something they are doing like that. So it is really very heartwarming thing for me that that the that PWC is doing wonderful work. Now coming to my presentation here, that which we are going to discuss today, the topic is this, and we know that the environmental hazards and disaster management using geospatial technology, one of the very hot topics these days, including the climate change implications. So climate change implications I'm not going to touch here, otherwise we go beyond that. But of course, the geospatial technology has a wonderful role in identifying some of the areas where climate change is affecting our landscape. So here we go. So what I want to say that our world, this world, the blue planet, is delicately balanced. Something like this, what we see here. Now, a lot of problem is there that we see that the forest fire is also there, drought is also there, epidemic is also there, and you name anything and everything is happening very fast. Now, the pristine quality of our nature has actually dwindled in a period of time, and we have this time around not a very good situation. So if it is balancing something like this on a pin hat, something like that, or a pan hat, in that case, it can go any side, that is the most important thing. Sometimes we think that what we can do, can we retrieve the valuable things which we have lost in the period of last 1 century or 50 years or 40 years? If you ask me the question, then I would say that perhaps not. It is not possible to get so many things retrieved from the nature again because it evolved in a very long period of time. So it is not possible. So what we can do, whatever we have, we could preserve. Slightly we can improve upon that and we can go ahead. So what we can do with this? So our Earth is something like that earlier, like that, the first one. And now you see that it is something like this. And see that a lot of gaseous molecules are just revolving like this, that, and then it's creating a lot of problem. So you see that this NASA data, what I'm showing you, I don't know whether you are able to see it in video forms or not.
Yes, sir, we can see it. Animation, we can see this.
So this is the actual condition. The left one, the first one is a rosy picture. Normally we show to the people, but actually if you go to any sensor, remote sensing sensor, our Earth is like this, what we see in the right side. So it is a very delicate thing here. Now, what we see here, that as you know, that geospatial technology is one of the very important technology which can provide us some of the solutions. And this solution we can utilize to decide and form our opinion, and we can execute it also. So there are three components, as you know already, that I'm just repeating it. Very important thing is that we have a satellite remote sensing or aerial remote sensing, you can say. These where satellites and aerial platforms are used, which can provide you the bird's eye view of the Earth's surface. It gives you all the information about the phenomena, whatever is there in the Earth's surface. And the second thing, what you see that the global positioning system, we call that satellite navigation system, which Madam already said that it can provide you the location, okay, correct location of the area. You can form a lot many roads also, everything by joining the points and all these things, coordinate values. So this is very important. When you have so much of data coming from the remote sensing or aerial platform or satellite platform or the navigation system, and you want to put it somewhere, to analyze it, for that you need to have a geographic information system. Now, this geographic information system is a versatile system which can give you the ultimate thing, that solution. First thing, it provides you what? It gives you the information about the area in the form of map. So you get various kinds of map, either it's a soil map or a forest map or land use land cover map of so water reservoir, wherever it is there, then you have so many things in the oceans also. So ocean floor information can also be done, it can be get, yeah, using indirect methods. So these can be done there. That ocean temperature also, whatever you are getting, so that can also provide you information about what is going to happen in near future with respect to the climate or climate change or monsoon and all these things. So this is the thing what you get in the map. But then what happens here ultimately, the main objective of the this geospatial technology, where GIS is being used, is where you want to do certain kinds of uh, calculations, okay, or you have to run some kind of models so that you get a futuristic model we call predictive model. So what is going to happen today? What is going to happen after 2 days or 10 days or 50 days or 50 years? All this kind of scenario you can create. So once you have this kind of scenario, you can go ahead and formulate your plan. You can execute your plan. So being the manager of the certain kinds of information what you're handling in these areas, administrator, you can decide on the kind of path you have to follow like that. So this is a versatile technology where you're using it very meticulously. And but then most important thing here is that these things are we're getting, but that man behind the machine, okay, we people, you and me and all, is very important that we are getting all information from the ground, that is the correct one, trying to link up with our data, whatever we are getting from satellites or some other sources, and then we're doing modelings like that. Now let's come to the platform types, okay? So these you know already that there are various kinds of platform. One is a ground platform. This lady is actually doing field work, okay? You can sample plot enumeration, you can say, or you can say any kind of work she is doing. So she is doing a lot of work there. So collecting all this information. The second thing, what you get, that you can get many information from aerial platform, means aircraft, helicopter, like that. So you can do that. And third thing that what you can also get, and people are getting very repetitively every day, that is from the space platform through satellites, different kinds of satellites, different satellite sensors are there, which are actually sensitive to different use, different objectives you can achieve from that. And then lastly, the new platform is being added in the last two decades, that is called your drone, okay, low altitude platform. So you see that you have 1, 2, 3, 4 platforms. Using these 4 platforms, you are trying to acquire information and then you are executing it and getting it. You actually get all these things, sent through it's a launching vehicle, what you call it. What you see here is your PSLV, ours, that shows PSLV satellites. And then what you see here also, that you get a satellite, okay, like this. Now, satellite moves around. I think it is also the video. Video is visible or not? No? Video.
Visible.
Okay.
Yes, sir, it's visible.
So you see that. So the second one, where you see that a satellite is moving from north to south, that is called your polar orbiting satellite. You know it? Satellite can move in any directions. That you have to decide where it has to move. So path has been pre-programmed by you to get the information. So different satellites are moving in different directions, like that. Now for the disaster management, particular, where you want to utilize this kind of data products where you have access, then it can provide you information in real time. That will come to that also when it happens in our that kind of things, real-time information we're getting that we can take immediate actions. Then it can provide also stew status, what is actually happening there, what is there right now, and it can give you the options also. So suppose NDRF, so NDRF people, they are actually they are the people, they go for the disaster management, the evacuate people and all that. So they utilize this type of things, where data products are also used using satellite or drone or any other means. And then they can decide also, and we can decide in the lab that what kind of scenario we can have if the things moves like that. That is called a predictive modeling. So predictive modeling approach is being done here. Now, this is the thing what you're doing here. Now, there are two kinds of disaster. So you know that one is a natural disaster, earthquake, it's happened. Then cyclone, which happens. We cannot stop it. But then there are many kinds of disaster which is man-made also, like pandemic. Okay, we do not know whether this pandemic is Chinese-made pandemic or the natural one. We do not know, but it is there, and we are not cautious. That's why it is spreading everywhere. So many people are killed, and it has come into the form of a disaster. So that is one thing where we can think of using a remote sensing GIS and navigation system. Let me come to Bihar. Okay, this is a flood. We're discussing about flood. Last time also you had flood also. Before that also, and there's a the occurrences of flood is there in this part of the world. Now you see that. If you see here that here in this portion, this is Bihar is there. Okay, okay. Now not many levers are there. You see that the blue marks are all where the due to monsoon, these are all inundated areas, okay, including Ganga and Yamuna and other rivers, and Brahmaputra is also there, like that. Now, suppose if I take up only your area, okay, and part of the areas of UP and Jharkhand, and if I go for studying like this, then what you see here, that I can look like this. See here that this is in 2000. There was a big flood that time, when this Kosi River, that is breached its embankment and water started gushing from this area. So satellite, what it is doing, that it can capture immediately all the kinds of informations. Now there is one satellite that is called Terra, okay, and there is one more sister satellite that is called Aqua. So Terra and Aqua actually cross the same area, one in daytime, other one is in nighttime. So it captures all the information like this and provide you all this thing in infrared domain. So you get all this information, then you color it, and then you know that how much of area is actually devastated, inundated in that particular area. So you see that there are not many things you can do here. So once you know that your area is inundated and water is spreading because satellites are moving always, and then it is coming again repetitively tomorrow, day after tomorrow, and many satellites are there. And you know that sequence of satellites movement in this area, providing you information about periodic position of the flood situation in that particular area. So a manager or the people, those who are administrator, those who are looking after all these things affairs, they can also take a measure. They can equip people. They can provide them the rescue operations like that. So everything they can do that like that. So I'm just showing you two satellites here. One is this is your Terra, this is your Aqua. Okay, this is not Indian satellite, of course. And then these are doing wonderful work. But then our own satellite, we have IRS series of satellites are also providing you a very important things using their beautiful sensors, where you have used also the microwave sensor also. It is a capability of penetrating cloud. So whatever is there down below cloud, that can be also assessed, and you know that how much area is also inundated. So this is one more scenario. You see that it happened that in 2015, okay, and then in 2015, when the normal course of river or something like this. But as we entered into 2016, August, this is a rainy season, monsoon season, he said that it is that there is a lot of water is there, and that inundated all this area. These are all clouds. So you see that you can access immediately all this area and you can provide the text there. Now suppose if I want to find out what is happening periodically in a period of time during flood season is a big one, monsoon period. So I can use several kinds of satellite data, and then I can analyze it, I can tag it properly, and I can georeference it. Georeference properly tracking so that one satellite data is exactly fitting over the other one, other season. So you have this kind of scenario. So a multiple situation is happening here where you have this kind of things where water is there in this area, red is here where you have flood, okay? Less floods are also there in this area. Something happened during previous time, they're all in green like that. So you have all the information. Now the management is aware that this much of area is actually sensitive area. If it is sensitive, then how to protect it from flood? So they can think of doing some action plan. So action plan they prepare and do it. Here satellite plays an important role here. So you get a multiple satellite data. All the satellite data are used, and then you get a very good map with respect to the area. Like Gaya is also there, Patna is over here like that. And these 195, all these things, these are all stations where you are going to collect the information with respect to the water flow. So these information are collected from this. So you know that how much water is flowing in that. Like that. And you get the information, something like that in a map. So you can mark it on the map like that. So this is one thing. Let us see in Brahmaputra Valley. So Brahmaputra, that is one of the very big river in India, and always it is in flood. So you see that this is a flooded area. Okay, this is here. This is your Meghalaya, and this is your Brahmaputra area where your Assam is there. Okay, this is your Bhutan area like that, and here Bangladesh is there. Now see that how much havoc is being paid in this particular area. Now suppose if I use infrared data, where infrared means that where using infrared sensor besides some other sensor, then you get a clear picture of the position of water in that particular area. Now, this is October 2020, okay, and this is 21, okay, April. Now, naturally, this is the period when water is there in that particular area. So flooding, flood period. Now see that this portion is the flood water has actually taken over the entire agriculture portions here, and you have lost so many crops and also livelihood of the people here. Comparing this with this, by 2021, again people started cultivating in this area like this. Now see that this is the cultivated areas because bunds are very clear, fields are very clear. These are all forested area. This is water already receded. This is called char. Okay, that island. So island, river island, small river temporary islands have been formed in this area. So you see that things are again moving in right directions like that. So what you can do here, as an expert, you can find out what are the area actually is inundated in the previous flooding, and you can mark it how much of the area gone, how much of the resources gone, and how much in monetary terms people have lost in this area. So how many livelihood has been lost in this area. So these kind of thing immediately it can find out using a satellite data. Coming to tsunami, the tsunami is a not a very common thing in India, of course, but it is happening in so many areas. While working in 2004, when tsunami took place, you know it. So I used to work in this area. Okay, so Pinklat item is there, Komota is also there, all these things. So due to this, we have used IRS data. Okay, and after using it, periodically what we did, that we use different data, we call temporal data to find out the changes took place after the tsunami. And then we saw that all this first one where you see that island is there, which is something like this. But after all, in 26 December, what happens, due to this particular tsunami, many of the areas are devastated like that. And finally, you get a situation today to something like this. So you get all the information regarding the loss of your resources in that particular area, and then you need to do a resurvey of this particular area. These are all statistically very important. You can also do certain kinds of modeling and other things to find out changes also. So these are the things, what you can see that what happened before and after tsunami. So like that. So you can, this is a Japanese work. So they have done all these things here in this particular area. So people are free to do work in there because they are all having access to the satellite remote sensing data. Now coming to a one more important area where long back people have realized that this area where you have very loss of life was there, Kedarnath area. So this Kedarnath area is one of the area, that where a lot of things happened and devastation took place. More than 10,000 people died, and then all these things were eliminated. What you see here today, it was not there. Only because they know what happened here, nobody actually knew. But scientifically, if you analyze it, then you come to know that the situation was something like this, because westerlies were there. Okay, a lot of clouds came from the western sides, Mediterranean sides, and that struck this particular area. Simultaneously, clouds came from the southern side also, and when they started walking in this particular area, or what you see here, then you see that the upper areas, have had good snowfall in this area. But there is one more place was there, the Chorabali Glacier over here. No, there was a lake here. So lake was full of water, after that. Now what happened that once it is having more than its carrying capacity, naturally it has to burst. These are all temporary things, that what happens here. So it happens something. This is a scenario that we can say that it happened something like that. And then what happened due to cloudburst or something like that, that one portion of the area given away and water started gushing out from this area. It's a very high altitude area, went towards down, so the speed was very high, like that. So it happens like that. And there was a lot of devastation, what you see. So what you see here is in this particular India remote sensing satellite data, what you see that Reaper started changing its course. And once its course was changed from here, you see that there are settlements here, and then you have a mandir here, Kedarnath Mandir over here. So naturally, it has devastated the entire area. So you see that lot many things are there. So people are started realizing that why not to preserve all this area for future. So different action plans were made like that. Coming to the landslide. Now, landslide recently, and you know it very well, that it happened there this year only. So what happened there? That you see that this so many areas were devastated, including that hydroelectric power station got. So what happens here, in fact, that you see that all the debris are coming from this upper reaches of the hill areas, and then also snow-fed areas. These are all snow-fed areas. So all things are gone. So it cannot be retrieved now. It's gone, confused. Now the problem here is that there's a human-induced pressure is also there. Now we had ambitious program in Uttarakhand to construct hydroelectric power station, and the total number is 45. So 45 is a very big number, like that. So one of the area, catchment area, what you see here, this area, Alaknanda area, itself is having these many things. Now see that these are all snow-fed areas, okay, and very sensitive area. If you construct something, and something goes wrong, it happened recently also. So you cannot stop it. So it happened like that. Now you see that what remote sensing can provide you here. Now remote sensing can provide you the true picture of this area, that what actually happened. We realize that this portion, as you know, all the papers are also flashing all this information, that a big chunk of area, this area actually toppled down 1,800 meters down. And once it went down, and hit the areas where glacial moraines are also there, so it created a lot of debris like that. See that all this blue color, okay, brown color like that, gray color like that. So it started goes down like that. Oh, this is the real picture, 6th, 7th, and 8th, and slowly it subsided after some time. Now, what happened here? That when something goes from that much of height and total area chunk of the area is 0.34 square kilometer, it's a big one, and going down to say 1,800 meter, it is a very important thing. So that it will definitely going to take over everything with it. So that's what is happening here. Now see that this is the close up of this area. Now, these particular satellites, what we are getting here, the satellites are very important here in a sense that this provide you bird's eye view, as I told you, and it can provide you information in real time, what happened during that period. So you see that the previous one, so something like this, a chunk is already going to crack, is developed here, and then it went down 1,800 meter, and that is a fall, and then it goes down like that. And subsequently, it settled down in this area, and you see that small lakes have been formed in this area. So this started moving downstream like that. So this creates a lot of problem like that. So you see that the satellite is providing you a lot of information. So real-time information also. It's a natural disaster, you can say. But then we had problem when you construct something unscientifically somewhere in the downstream. So that's what happened here. And then when a new lake was formed like that, and it happens in the Himalaya. It is not a new thing that lake is not there. So lakes normally happens there, and ultimately the river also find out way to take it out. So it's a natural process. So the new lake has come out. But the problem is that if water level remains like that or increases, and if there is a burst in the area, then the downstream areas will go. So that you have to plan that what you have to do here, whether you have to make way for the water to move from this area, it means that you have to remove some of the soils and debris from this area so that the movement is secured like that. So it is like that. See that in our area, it's a very funny area. We are having, everywhere people are constructing roads, without thinking anything like that, and they are throwing all the, you see that debris on the river. So you see that it is creating a lot of problem here. And then Himalaya, as you know, that is a very young mountain ranges. So whatever you have, whatever you construct, next day it is not there. So like that. So it is like that. Now, one thing is there. Suppose if you want to find out anything in real time, when satellites are not there in that position, then you can use your drone also. Okay, so UAVs are versatile things. For a smaller area, you can do a lot of survey, and you can find out which are the areas which are actually sensitive to the landslide. Like this area, this is your Nagaland area, okay, national highway. This is national highway, and geoccurrences of this landslide is always there. So you know that you have certain points here already. You have taken information from that, and then you try to find out that when this particular area will have more landslide, or you have to change the area of alignment of your road to from some other area. So that kind of thing is being done. So here and real time that UAVs are being used very effectively to understand the what is going to happen there. So you can do a lot of hazard simulation mapping, and this is very popular in the hill areas like ours, where drones are being used. Also, it is very effectively used to find out what are changes going to happen after a period of time due to monsoon or something. Now there is one more technology just creating waves these days. That is called LiDAR, the light detection and ranging, it is called. It's a kind of remote sensing only. Now, the beauty of this particular technology is that this can give you information of everything, almost everything on the ground, because it can collect information in the form of small points. These points are actually measured, and you get the terrain complexity maps also. In other words, suppose you have a forest like that, and you do not know where landslides are there, all obscure due to the big tree cover in this area, but you want to use this LiDAR technology, you can find out where it is, and then you can find out this is the areas where landslide has taken place. Otherwise, it is not seen from the top. It is very difficult to see it the top. So what is happening here? LiDAR is a very, very important technology. It gives you information accuracy in the form of millimeter level. It provides you a lot of information for the managers, the specialists, those who are going to work on these particular areas to stabilize the landslide areas. So LiDAR is one of the very important things here like this. Now, ultimately what happens here? So you are actually going to get preparing, okay, for any eventuality. Then you are responding it. That's it. You are also recovering it because once something happens, you try to recover. You want to evacuate people also, and you want to try to stabilize things there. Then you take a decision to mitigate it, how to solve the problem. So this is the main crux of the issues that's being tackled in this particular things. Now, one more thing has been added here, like during Kedarnath disaster area only, disaster period only. That's how you can do the emergency management. Now, fortunately, what happens, these days everybody is having mobile. Okay, so mobile is having SMS. No, and these hill areas, wherever you go, you will find mobile towers. Now, suppose you are stuck off somewhere and you have seen some landslide is there or any kind of things happen to say forest fire is there. So you can SMS the information to the control room and and you also give them the coordinate. Immediately people come and try to rescue people from those areas and try to mitigate the problems there. So mobile has become one of the very important things in these areas. So we call geo SMS. So geo SMS messaging technology is also added in this, where you can use it very effectively. One of the perennial problems for us is that we people have actually devastated our forests. Since civilization, if I say that this is 7,000 years approximately, till now, we have already consumed 60% of the forest in our planet. 60%. So that is actually proved also, statistically proved also. It has been done there. And whatever we have, that we have now degraded forest. Most of the areas are having degraded forest. So degraded forest is forming due to the deforestation. Now, deforestation is happening due to the man's requirement because man requires more and more things, okay? And then forest is the ultimate user. Now, this is one scenario I'm showing you. This is a satellite remote sensing data of Brazilian area, Amazon, right? 1986, the date is 1986, where these are all very dense forested area, right there, see that. And then what happened here? The people started entering into the forest and removing the trees from there. You see that lines are there. Ultimate aim was to create a range here. Okay, some plantations and all these things. So they are removing it systematically like that. So what you're doing, actually, you are monitoring it. So you want to know that whether your forest is intact or not, or it is being devastated by the people illegally. So that's what you're doing. In 1986 is what happened. Well, in 1992, what happened? They penetrated even more inside. See that? And then they removed a lot of forest in this area, and then they started cultivation also in some of the areas like this. And by 2001, you see that the big chunk of area is converted into, say, agriculture fields like that. So natural forest form. So the change in the forest area due to deforestation or any other means or fire or whatever it may be, that it can be monitored very, very effectively using satellite remote sensing data. I will take you to some other area where you see that how human intervention is actually playing havoc in national park area. Now, national park is called a protected area. In protected area, you are not supposed to pick up a small thing, a twig also you cannot pick up. So that is a kind of rule one has to follow. But what happened illegally, people go inside, they cut trees, they also take their say, goat and sheep and other than grazing activities also going on like that. In the process, they are actually degrading the forest. And the ultimate loser is the wildlife, because wildlife is they're what they're doing, they are inheriting certain kinds of diseases. They're also finding that their area where they are supposedly there should be there is actually devastated. It is no use for them. So like that. So I will take you to Ranthambore. Ranthambore in Rajasthan, and in Google map photograph, you can see that imagery, it looks like this. It is green one. Okay, this is Ranthambore. Now this is a true color. What you see here. Now normally, if remote sensing, in true color you cannot do much work. You cannot find out or differentiate many things here. So what you can do, you have to use certain kind of other sensor like your infrared that can be added to find out some important things. So let us see this. So here infrared is used here along with some other things. You get an FCC, you know that false color composite you can make it. So here all the vegetated areas that includes your agriculture, forested area actually appears in red color, different shades of red. So you see that it is there. And also in between, you see that the blue grasses are there. These are all your grass patches, grassy patches, okay, where herbivore normally used to graze in this area, all in senescence period. So like this, and these outside area, what you see here, are actually devastated. So this is a core area inside one. This is a ribbon, okay, yellow ribbon, and outside is here the park area. This is your buffer. So this kind of thing you're having here. Now, if I want to find out how much intervention is there in the forested area, so I can do that. Now, before that, what I can do, I can create a 3D model also. Now, this is a 3D model of the same area, okay, where you see that forest is coming in red. You have mountain ranges also. You have escarpments here, okay. You have valleys, okay, and then you have many more things here like that, here, like this. So degraded area is also come up very nicely here. Water bodies are very clear like this here, and Ranthambore Fort is over here, it's like that. So I can do a lot of work here. Suppose if I make it in 3D, then definitely I can study many areas. So close up view I can take. For example, here. Now suppose if I want to mark which are the area which are actually degraded, roughly speaking, something like this. Now see that. Now this is the area, what you see here is your yellow ribbon actually giving you information that these are the areas under definite stress. So definite stress is due to the human intervention, okay, like that. And then if I want to see more in this area, now see the green ribbon is also there. These green ribbon is actually the wheat, which is infesting in that particular, this infestation of the wheat we call Prosopis juliflora is coming up in this area, which is of no use for tiger. Now this is the abode of tiger. Tiger, if they go to these areas, and if this particular Prosopis juliflora, where its thorn is very big, it puncture into his pug, then it is not going to kill anything. It will die without killing. So these are detrimental to the cause of the wildlife management. So it has to be removed. So this satellite data providing you a lot of information about the weed infestation in the areas, also the degraded areas like that. So these kind of things are there. Now suppose those who are doing research work, like you have research PhD process, they can do a lot of work here. For example, they can take a cross section of a given area and find out what kind of resources are available like this. So that gives you the area when you do the sampling work in this particular area in a transect, then it provides you a lot of information about the different kinds of species going in that area, where red is the invasive species. These are all areas where structural denudation are there. These are gone. And then you have a good forested area here like that. So, and then alluvial plain is also there. Beside that, what you do here that you can find out the correlation between the soil, the geology, the landform, all these areas. So see that. So you can create a corridor and then it becomes a PSC work also. So this is a wonderful thing, that one can do and then visualize it and then do a lot of work. And using all these things, using other parameters that collecting all the information from the ground, we call sample plot of enumeration, where you are doing it in the transact for this particular work, then you can come to the conclusion that these are the area is actually degraded beyond any repairing in coming years like this. And this is high pressure zones are there. So if you convert into the pressure zones, then you have a pressure zones like that. So GIS is providing you information. Then the satellite remote sensing is providing you information. The ground survey is also strengthening your information database, and you get all this information very correctly, and you are getting a very good information of that particular area. Ultimately, what you need in these areas, that you need to provide information about what you can do after that when you know these kind of things are happening in this area. So what you can do in this area, you can make an action plan. So what you can do to minimize pressure in the national park area, so that you have to create a biomass outside the area. Okay, and these kind of biomass, what is I have already specified here. If you do this, then your national park is safe. So this is the kind of work you can do this year. One more area, two national parks are there. Okay, one is your Corbett, okay, in our area, towards my left, and where I'm sitting, it is your Rajaji National Park, Dehradun area. So now what is happening that we have a lot of elephants there, 180, 140 elephants, they move together, crossing Haridwar area. There's a big impediment there, okay, because human intervention is also there, railway lines are also there. People have also started constructing new houses, and then most of the forested area is also converted into agriculture use. Now, these bad animals, normally they need a lot of food and they move in group. So what happens here? They have to be protected. Now, suppose if you want to study something like that, and then if you give some suggestion that this mega element should move from this area where intervention should not be there, then fine, but it is not happening. So remote sensing here is providing you the how much pressure is there and what is going to happen after a period of time. So let's see that in this area. Now this is India. Okay, we have a forested area something like this. So green is your forest, not much. It's 22% approximately, and most of the forest is in the hill areas. You see that hill areas. Okay, so it is like that, and you see that here we have one area we have already marked. This was the area, previously elephants used to move very freely because human intervention was there. Not many villages were there, not many agricultural practices were being carried out in this area. From northeast to north, so extreme north, almost you can say that Haryana and beyond Himachal Pradesh, these elephants used to move. Now these are two national parks here. You see that. Two. This is your Rajaji National Park. This is your Corbett. No, I'm trying to show that here. This is your Rajaji National Park. This is what you're seeing. You're seeing FCC, Fox Color Composite. Now, this is your sal forest. And this elephant, they love sal. Okay, they can eat bark also. And this is your Haridwar area. Okay, this is Ganga River. So they have to cross Ganga River to reach to the other side. But then you have many villages. The army camp is also there. Okay, so these kind of things are happening there. Then next one is this is your one other area, which is called a Corbett, relatively safe. Okay, now this is a Dikala area, we call it. And then this is quite big, 800 square kilometer plus area. And then elephant, they start moving from this area to here. They venture in this area. Sometimes they stay here, again go back to their area, so original area, something like that. So you see that lot many villages also there. These are all small dots are there, yellow dots. These are all small villages like that. So these are all again impediments. Now I will superimpose this, okay, over this particular map. Now you see that what happens here. You'll understand this. Now you see that this is the area, okay, and here I put this Rajaji National Park over here. Then other one, I put Corbett National Park here. Between this, there's a gap, big gap. This gap is a very sensitive area where they have to pass through these areas to reach to either this national park or this national park every time with the group. So that's what the problem is there. So you want to study how you can do that. So you can study it using like this. So this is the area. This is the historical part they are having like this, like this. So this is a thematic method data, right? So in thematic metadata, you have created a DTM, okay, digital terrain model, where hill areas are also depicted like this. And you know that the hill areas are not suitable for elephant to move. It cannot move in these hill areas. It will fall down and it will fracture its legs and bodies, bones. So it is very difficult. So it is not possible. So what will happen here? So they will start moving it from a secured area like that. And this is a historical part they used to move there earlier. Now all Euro areas, is converted into agriculture. So very precarious conditions. So in 1990. Now you compare this with the other one, okay, 2008, after 10 years, you find that some areas have gone degraded also. Same area, okay, and then you have classified it, land use, land cover, or you can say the forest type map also. You can create it like that, and then you find the degradation map, something like that. It means that the resources for this particular elephant is reduced here, like this. Now, what happens here in 2015, the scenario was like that. So what you're doing, you're using a data, temporal data of 1990, 2000, 2015, and then once you have this data, so you have a fair amount of information about this particular area. So what kind of land use, land cover is there presently, like that. Now, suppose if you want to do certain kinds of modeling here, what should be the corridor of this area? So by 2020, last year, because this work was done earlier, it was actually estimated that time that the corridor will shift 0.5 to 3 kilometers down up there. Means that towards the hill areas, like that, towards north. So it means that it is a very, 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 very sensitive things, that they cannot move, but they have to move. Now, how they have done it? They have done it using a modeling technique that is called spatial regression modeling. Now it's a statistical method. You can also do it. This is for the researchers, those who are doing research work in Patna Women's College. For them, they can work in tiger areas or any other areas like this kind of thing. They can duplicate this, some kind of information they can carry. So this is one thing what happened here. And one more important areas in our area, particularly hill areas everywhere, right from say Kashmir to Arunachal Pradesh, we have occurrences of fire. And most of the fire is actually man-made, induced by people, 99%. It is not natural like that. Scenario is something like that. You see that fire is here. Then plume of smoke is coming out from these areas. This is called cheap pine. Cheap pine is a very volatile thing. So it can provide a lot of fuel to this fire. So it happens like that. Now, what remote sensing can do here? So remote sensing can provide you information in infrared band. Now, infrared, the short wave infrared is there, which can penetrate your this smoke cover and provide you where active fire is there. This is, see that active fire. Otherwise, the normal infrared is not going to provide. It is not able to provide you information like that. No, let me do it like this, okay? And see that. And you get information something like that, where you have fire, which is come in white color. This is the active fire, and these are the fire already gone. Nothing is there, and still it is under fire. Okay, this is something happening in this area. So you know that how much devastation has taken place in a given area. Now, what happened here, that India and other countries have a big protocol. Our National Remote Sensing Center is pioneer in providing a real-time information of the fire in any given situation in any part of the India and also adjacent countries, including China. So what happens here that satellites are moving, they're capturing informations, they are passing on to the Hyderabad center, they are analyzing it, they are passing it to some other centers also, like Dehradun is also there, where Forest Sub of India, they are also doing it. In Northeast, they have Northeastern Space Application Center is there. They are collecting all the information and sending back to the people, those who are actually managing forest in those areas. Like say Nainital is there. So Nainital DFO is there. Division Forest Officer. There they will send it. Look here, the fire is there, moving towards this direction. This and already engulfed this much of area. Everything they tell, and they are using their resources to extinguish fire. So that kind of thing is there. Situation is there. So what I am going to show you here is that yeah, it's like this. You can also model this like this. I think you can see it. See that plume is there, plume of smoke is coming out from this area. This rat is your active fire. I think you can see it.
Yes, sir. Yes, sir. You can see it.
Then this is a Nainital Jheel. You see that, and just over that, they have universities there. Over that, fire is there. See that. So a lot of area is gone. These are all almost man-made fire engulfed a very big area. You see that it is happening like that. So I'm very sorry to say that we are spoiling our forest like that. We do not have much forest. Still, we're doing it, and not much accountability is there. But then your technology is giving you the right information, right through the people up to the higher level. So it is like that. So what happens here that sorry. So see that these are the areas, and I'm not 2016 to some of the areas, this is equivalent to the 1 square kilometer area. These are pixel sites. They are having fire in different period of time, different dates like that. So everything is information is provided to people like that. So we have a disaster management support program where we do all these things here. So NDEM is doing all these things, collecting information is making is also going on, and rescue operation is also being carried out like that. So now next comes your drought. Okay, the drought is a perennial situation in India, and a lot of work is going on in this area. What we do here that you collect repetitively satellite data of various seasons and also try to see that your crop is going good or not. That is the most important thing. So you are monitoring it. Once you're monitoring it, then you know that what will be the total production in a given period of time. So India knows that our production will be less or more. Accordingly, they will adjust themselves. Either they will import it or export it, or they will store it, something like that. So satellite is doing a wonderful job like that. Two scenarios like that. One is when October, it is just after your rainy season when you have a kharif crop, and in October 31st, there was a lot of areas under say this thing, the drought conditions were there. So all monitored very effectively using different kinds of satellites, different satellites data, whatever we are in our position, including foreign satellites. And then in April, that Rabi season, that particular area was something like this. So again, rejuvenated this area. So we know that our Kharif crop has actually dwindled in this period of time, and Rabi crop is doing okay like that. So accordingly, a manager or decision makers plan the things whether they have to import or they have to export or they have to store this kind of things there. Another thing what you do here that your health of the agriculture crop is very important. And for that, again, you use infrared data, infrared sensor to find out what are the changes that have taken place in your standing crop. Using that, you know that how much changes have taken place, how much, where any kind of stress is there. Stress could be due to the water storage, it could be any kind of disease, infestation in that particular area. So it happens like that. So you know that how much crop productivity will be there. And if you want in real time, then you can give certain kinds of prescription so that these crop again becomes okay. in a period of time. So periodically we're doing it to find out. And best important thing is that you know that in digital image processing there is one NDVI, normalized difference vegetation index. Normally we do that to find out the health and vigor of the plant in a given area. Using that parameter, we know that which are the area are having healthy plant or which are the area having the poor quality plants like that. So crop conditions are known. And then earthquake is there, one more area. So earthquake, you can also, you do not know much, we do not know when it is going to happen here. So, but then after earthquake, the most important thing is that how to take action. That is more important. And how to do survey work. Fortunately, these days you have drone. Okay, this is a quadricopter. Okay, these can move around the area and find out what are the damage, total damage area. Now, I will show you one of the area where in 2015 there was a big earthquake took place in Nepal. Okay, and then Darbar Sahib area I will show you. So Darbar Sahib area is something like this. And after devastation, it was like it. People are standing there. This is a model, right? Taken from your quadricopter. It is taken, and you see that a lot of damage has been taken place. This is one of the area where damage took place like that. So this is a tourist place also. And then from different side, it is something like this. See that. So you, this copter is moving around and taking informations from different directions and providing you a model which can provide you information about the total damage in this particular area. Similarly to the other areas also where you want to take action immediately or after some time. Next comes your cyclone. The cyclone is again a perennial condition, perennial things in Indian context everywhere in the world where this is done, this is happens every time. Now in India also 3-4 this, this kind of situation we always face like that. And then what happens here in this particular area, you see that after devastation, this is what happens here. After devastation, you take the satellite data. Before that, it looks like that. After devastation, it's something like that. So you know that how much loss of life is there, property is there, how much construction activity should go, what, how you can manage it. All this thing has to come through this. So this was 315 kilometer per hour typhoon we call it. This is in the Philippines area. Earlier it happened like that. But in India also we have cyclone storms, and fortunately our system is very very good, where we can find out beforehand that when we are going to have cyclone in a given area, at what speed.
Excuse me, sir. Sorry to interrupt. Sir, we are crossing our scheduled time.
Okay, how much time you can provide me?
Sir,
5 minutes?
sir, yeah, 5 minutes would be fine. Yes, sir. Thank you, sir.
So like that. So this is the thing, this is happening. So I'll just skip it. I wanted to show this also. You see that volcano eruption is there, and then volcano eruption satellite is picking up. And these days, satellites are also having different kinds of sensor and movies. Okay, videos are there. So these videos, you can see something like this, that the plume of smoke is coming out, and you can evacuate people accordingly, what direction it is going, where what kind of things are happening, all these areas like that. So I'm just skipping all these things, okay? And I wanted to show one more thing that very important, that was the birds. That birds are the messenger of so many things. They provide us information about impending disaster also. And for that, this you see this, you try to understand this. This is yeah, satellite taking. Okay, so birds go from one end to another, and then because these are geotag, so connected with the satellites, and its position, and coming in here to here, in the South African area, Lesotho areas and all that. And when it comes back to the Amur area, this here, back to the Amur area for roosting purposes, then they already travels 20,000 kilometers. And if they change the route somewhere like this, it shows that there is some problem is there in the atmosphere. So that it gives us some certain kinds of alert. These also provide us information with respect to the disease it is carrying or any kind of impacting disaster. So birds are very important for us. So this is the last slide I'm showing you, wrapping up.
10, 9, 8, 7.
This is for the student.
5, 4, 3. We have ignition of the RS-68 engines. 2, 1, 0. We have liftoff.
So thank you very much. So this was I wanted to share with you.
Thank you so much, sir. from the application of remote sensing GIS and GPS to the flight of Falcon, the geospatial technology is now well established and well accepted too, more so in the field of disaster management. Thank you very much, sir. You made us understand the dynamics of natural disasters and the application of modern technology for the effective management, citing ground level examples. Thank you so much. Dear participants, the link for the feedback form is already there in the chat box. You are requested to kindly click the link for filling the feedback forms. On the basis of the details you give in the feedback forms, your e-participation certificates will be mailed to you on your registered email IDs in a couple of days. We will also mail the link to your register mail IDs. So in case you miss out the chat box link, you will be receiving the link in your respective mails also. Thank you. All well that ends well. As we come to the last stage of the event, I call upon Ms. Meenakshi Mishra, Assistant Professor Geography, Patna Women's College, and the Joint Organizing Secretary of the National Webinar to propose the vote of thanks. Over to you, Meenakshi.
Thank you, ma'am. A very warm good evening to one and all. In the words of Eckhart Tolle, quote, "Gratitude for the present moment and the fullness of life now is the true prosperity," unquote. As we reached at the closure of the event, I take this opportunity to show my sincere gratitude to all of them who have contributed to make this national webinar a successful one. At the outset, on behalf of the entire Patna Women's College family, I offer my heartfelt gratefulness to our respected resource person, Dr. K.K. Das, former scientist, Indian Institute of Remote Sensing, Dehradun, for sharing your expertise and elaborate presentation on mega geospatial technologies for the 21st century and its relationship in scientific research, especially in context of environmental hazards and disasters with the participants. Sir, kindly accept our sincere thanks. I'm very much thankful to our respected principal, Dr. Sister M. Rashmi AC, for your immense support and constant encouragement. Thank you, sister, for always being there. I sincerely thank Dr. Sister Tanisha AC, Vice Principal, Patna Women's College Autonomous, for your motivation, encouragement, and cooperation. My heartfelt thanks to Dr. Debjani Sarkar Ghosh, Head, Department of Geography, Patna Women's College Autonomous, for taking the quality initiative, your perpetual support, and valued inputs. My special thanks are due to Dr. Amrita Chaudhary, Coordinator, IQAC, and Assistant Professor, Department of Geography, Patna Women's College Autonomous, for your meticulous planning and relentless support. I show my sincere thanks to Sister Anna AC for initiating this webinar with her soulful prayer. I'm thankful to all the members of the Department of Geography, Patna Women's College Autonomous, Dr. Avdesh Kumar, Ms. Aishwarya Raj, Dr. Arvind Kumar, Mr. Kundan Kumar, Ms. Rebecca Tiga, and Mr. Ignatius Tirki for your wholehearted support to make this national webinar a successful one. I also thank all the participants of Geography Fraternity across the country for being present with us virtually and for your interest shown towards the event. This is all for today. Over to you, Amrita ma'am.
Thank you, Meenakshi. May I now request all of you to kindly put on the camera, please, so that we may capture these moments. Kindly put on your camera. Your photographs, your smiling faces will be our pleasant memories. Meenakshi, just take some screenshots.
Sure.
Thank you, dear participants, students, researchers, faculty members.
Thank you, sir, for your nice and lively presentation. Thank you, Amrita, for
Thank you all.
And
Meenakshi, are you done with the screenshots? Okay, thank you. So the time has come to part and bid adieu. Let us part to meet again in future for a good cause and for a valid reason. Till then, goodbye and good luck. I request all of you to kindly rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, sir, once again. Thank you, all the participants.
Thank you all participants also.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
next time we'll expect to visit in our college, and we can have offline seminar also.
Okay, Meenakshi, thank you, sir. We will look forward to hear from you once again in future.
Thank you very much.
Thank you, sir.
Thank you,
sir.
So I'm ending this session now.
Yeah, your link will be mailed to your email IDs also. So kindly, you give your feedback, you fill your feedback form, all the participants. Certificates आप लोगों को 2-4 दिनों में मिल जाएगा. Thank you. Okay, Meenakshi.
Yes, ma'am. I'm ending this session. Thank you.
Thank you.
Thank you.